Hi, my name is Connor. I'm part of the data success team here at Ikigai. Today I'm going to be walking you through the DeepPlan and labor planning application demo. Here we're kind of in the landing page of the dashboard. Here's where you'll look at your different labor planning policy simulations, as well as picking and actually going through your desired labor plan. The first step of this process would be to input your yearly budget in the input box here and to click Generate Simulations. This will take into account your yearly budget and generate optimal labor planning policy simulations that fall within that budget. So after that runs, the dashboard will refresh. And now we'll see the labor planning simulation scatter plot populated with different policy pairs. So the way you can kind of interpret this chart is by first understanding the two axes. So on the y-axis, we have the service level unmet. So a higher service level unmet is actually worse, and we want to try to keep the service level unmet as close to 0 as possible. And here we can see the x-axis is the average show hours. So really the optimal kind of balance here would be minimizing average show hours, which therefore minimizes your cost, but also minimizing service level unmet, so you're able to kind of meet and achieve all desired service levels by the client. So in this scenario, our optimal policy is actually this kind of point here, where we're getting around 71 average show hours and a perfect service level. So we can see that actually translates to a particular policy pair that is 1.2_212. And what those values actually kind of mean and translate to is the first value is the aggressiveness of the policy. So the aggression can either be 0.8, 1, or 1.2. So in this case, this is a more aggressive policy, meaning we expect people to work at a higher throughput, and we're kind of that's why we're able to get the hours lower in this policy. And the second number is actually the throughput itself, which means the number of units divided by the number of hours. So really the units processed per hour. So once we've kind of analyzed this chart and decided on our optimal policy, we can actually go to this filter here and select that policy. So 1.212. So once we've selected that policy pair, we can actually get into the rest of the dashboard here. So let's first start by looking at some of the KPIs on the right-hand side. So what this shows is for a particular pair, for this particular pair, we're saving on average 22 hours per day as compared to the actual policy that was implemented by this demonstration data. We're also seeing that our service level unmet has improved by 40%, meaning we're achieving service level 40% more of the time. And we're actually saving $147,000 as compared to the current labor cost of $611,000. So ours is going to be around $450,000. So once we kind of understand at a high level what this policy is doing for us, we can then kind of drill into some of the more granular data points. So here we're seeing a daily Ikigai labor plan. So for every day we generate a forecast, which is generally speaking more accurate than the client provided forecast. We're also generating or planning hours of labor per day. And we're also planning a particular throughput that we feel people can achieve every day. So the key saver here is our more optimal forecasts, or our more accurate forecasts, which allow us to generate more accurate hours. So we're not overstaffing on days where we expect a higher inventory to come in. So we kind of require the accurate forecasts as well as the accurate throughputs to generate more accurate hours. And you can kind of compare these against the current labor plan or the actual values for these same time steps to see how we compare. So once we kind of understand our daily plan and we're happy with that, we can also look at a few other metrics and reasoning behind the plan above. One is the throughput distribution. So we're seeing here that, over time, throughput values vary. So this is a histogram of actual throughput values for this time frame. And we're seeing that people are actually able to achieve high throughput values. And if we can, encourage and assume those throughput values can be met on a larger time frame, we're then able to actually recommend those throughput and expect those throughput values in our plan above. So essentially we're looking at historical throughputs, picking some of the higher percentile throughput values, and we're utilizing those in our labor plan. And finally, we can also take a look at the performance metrics. So here we have a line chart. It touches on many things. We're able to compare, all of the actual values, whether that's the service level, throughput, or hours, against the Ikigai values, which is our forecasts, our throughput, our hours. We can actually just drill into maybe one example. If we pull up Ikigai's forecasts, and then maybe we pull up the current forecasts. I think those are two values. We can just kind of see how those values compare, and essentially our forecasts are going to be more reasonable, more accurate to what the units actually coming in are. So yeah, that's kind of the summary here of the DeepPlan and labor planning app. Just to quickly recap, we start by providing our budget. We analyze the potential policy pairs that fall within that budget. Once we've decided on which pair to go with for our labor plan, we select that pair, and then we kind of can drill into the daily values and overall KPIs on how that policy pair will affect our overall labor planning process. Thanks for watching.